You remember this? Yeah, because in electricity we said if the electron goes this way, we say the current goes that way. So which is this, left or right? Left. So current is going left. No,
force.
This is the force. The field, the current. The field is going north and the current is going that way. So for me, the force is going into the paper. Did you get that?
So why is the force going like this? Like okay, this and not this.
What? What way is your thumb pointing? Up or down?
Down.
And that's what I just said. The force is going into the paper.
What am I doing?
How do you know?
Which side?
Oh, because like it's a Y.
What way is your thumb pointing? You
But
just did that.
It can be like this.
No, it can't. Because the current is going the wrong way. The current is going to the window.
Current is left.
Current is left. Yes.
Current is left.
This is going left.
Magnetic field?
Going forward.
Why?
Because I said that in the question.
You say why?
Yeah.
Why not y-axis? Why not x?
Because I described it as being on a piece of paper.
You did?
A bar magnet lies horizontally on some paper. A bar magnet lies... Did you want me to say a bar magnet lies horizontally on some graph paper? Would that have helped? I thought you could go... Oh, never mind. Can I go on to number 2 now, please? You're not happy with this. I don't know why. Why aren't you happy with this?
Because you can do this. Okay.
No, you can't. Because, wait, stop. Stop.
Okay.
Don't move. Which way is your index finger pointing? To you.
Yeah.
And I said in the
That's
question... Yeah, I said it's pointing the other way in the question. Towards the board.
Okay.
Now, which way is your other finger pointing?
That's in the board.
Now, which way is your middle finger pointing? To the door.
Yes.
That's wrong. I said the current's going that way. Which way is your thumb pointing? Into the paper. This is the only configuration that matches what I said. Is this okay, Warren, as well? Is it? You make teachers sad. But that's okay. I'm used to it. Right, 2. Was number 2 okay? Was it? Because now I don't know anything anymore. And what's the formula here?
B equals to
Flux over area, which is 0.4 over 0.02 squared. And what did you get here?
Nice.
1,000.
This is not
Exactly
my
1,000? Awesome.
It's not yours.
What?
It's mine then.
Where is mine?
A square region.
It's a square.
It's like a confinement.
Oh, this is mine.
Not a circular region. Dude! If this is right, and you got 1,000 Tesla. So 1 kilo Tesla. 3.
But at the center of the paper, it would be the same, yeah? Like it won't make a change.
No, we say the flux is 1,000 Tesla over the entire
But in
paper.
the question, they said center.
Oh, I see. Oh, well, it's flux density. So, no, actually, I said center, but I didn't even have to say center. I could have said through the paper. Why did I say center? I didn't need to say center. It's redundant. You know this word redundant? Yeah. It's like if I said, what is the pressure on this tablet, or what is the pressure at the center of this tablet? It's not necessary for me to say that. Right. What about number 3? An electron moves perpendicular to magnetic field of flux density 0.5, and the velocity is 0.01 c. And what is the force? So what formula do I use here? I just need QBB, yeah. The Q is E, the V is 0.01 times 3 times 10 to the 8, isn't it? And the B is 0.5. So that would be E times 1.5 times 10 to the 6. What's the value of E? Do you have it on your calculator? Stop inhaling your book.
It is 1.6
Look, you have a calculator. Tell me what E is. Thank you, Yahya. 1.6 times.
times to the power minus 20.
Okay, Yahya can. No, never mind. No, I don't need you. I don't need you.
Okay.
You're a strong,
I
independent
can. I
woman.
can do this. This will be 2.4 times 10 to the minus 13 newtons. I told you I didn't need any of you. Okay. Did you get this one?
No, what was the question again?
What's the force?
I got into the station.
Why? Why? When I asked what's the force? We were having a bad day yesterday.
Question.
Yes.
Why is it negative 13? It's
Minus
6, 6 and
I'll just
19.
wait until you figure out why that question's ridiculous.
Minus 19 and 6.
It's an electron.
Yeah, but...
Minus 19 plus 6 is...
Yeah.
It's 1.5 times 1.6.
You just let me know when you're finished being ridiculous and I'll resume.
Are you done, Wong?
Are you ready for me to continue? You've answered your own questions?
Yeah.
Okay. Number 4 now. Did anybody get number 4?
Attempted reading it.
Attempted reading it. The English, I'm sure, was quite difficult. Did anyone get number 4? No? No? Okay. I've seen this in the exam. In fact, it's common enough in the exam, and I hope when you see it, it won't be as hard as you think it is. So a particle enters a magnetic field at that speed, perpendicular to the field. So it doesn't really matter what way you draw it, but I'll just draw the field pointing up. It doesn't matter. The key thing is that the particle moves perpendicular to it. Yeah. So the particle then is moving this way, perpendicular, at a speed of 0.05 the speed of light, and the mass is a minus 10 to the minus 25 kilograms, and the charge is minus 2e. So, which way is the current in this picture?
No, it's right.
Very good. So the current is going to the window here, correct? Which way is the field going?
Up
So this way. So which way is the force?
in the picture.
Yeah. So what will happen is that this will want to curve around. You can't quite see it, but it's curving into the background. I'll try and draw this in more than 3 dimensions now.
We used to show the in and the out with the dot and the cross.
I know, but I can't really do that when it's arcing in. That's fine when you're looking at it head on, but what's happening here is it's curving into the background. Anyways, I want to know what is the radius of this circle. So, firstly, let's get the force or the acceleration. F equals ma, which equals qvb. So A equals qvb over m. Is that okay so far? But what type of acceleration is this? It's circular acceleration. And what is the formula for circular acceleration? V squared over r. What can I cancel here? A v. Yes? And then I can divide by v, and I get 1 over r. Therefore, r equals Vm over QB. Not so hard now. So the radius will be 0.05 times 3 times 10 to the 8. Yahya, can you give me the mass of an electron, please? It's constant number 3, I think.
It's 9.1.
Yeah. 10 to the minus.
Minus 31.
And then also, what was the E again? It was 1.6.
1.6 times minus 19.
And there's 2 of them. And the B, did I tell you what the B was? Yeah, 0.75. Okay, so if you just type in 0.05 times 3 times 9.1 all over 1.6 times 2 times 0.75 times 10 to the power of 8 minus 31 plus 19. So that's minus 31 plus 27, which is minus 4. Does anyone have this fraction?
I have the final answer.
Oh, you do? Thank you. What is it?
1.28 times 10 to the minus 4.
Yeah, okay. And that's quite small, actually, smaller than I thought. No, I made a mistake. What was my mistake?
The question or with
No, with my workings here. I was wrong to use 9.1 times 10 to the minus 31 as the mass. Why am I wrong to do that? Because the question didn't say it was 2 electrons. The question said it had the charge of 2 electrons, but the mass was 10 to the minus 25. Could you fix that up if you have it typed in? That's better. 14.1 meters. It is big, so what will happen in real life is it won't actually complete a full, it won't even complete a quarter of a circle, it'll just be deflected slightly along a circle of radius 14. So when you look at the mass spectrometer, the radius will be pretty big because all that's going to happen is the particles will be deflected slightly, but they won't actually make a full, even a quarter of a circle. You've done the mass spectrometer, haven't you? In fact, I think it's one of your courseworks, isn't it? No. But it's an exam question. It's a classic chemistry exam question.
Yeah, I'm not getting 14.1.
Alright, I was like, chill. Give yourself a break now. What did you get? And I can trust you over Yusuf?
Yes, yes. So this will be our same answer.
Different power.
Gimme!
I have 62.5.
6.25.
We're going with that. Thank you. Okay. Is that question okay now? Not as difficult as it seemed, right? It's an exam question. Question, please. Question or get out?
10 power negative 25. 10.
Yeah.
Yeah.
Faisal, either ask me a question or be quiet. I'm continuing.
Okay.
Next lesson, we shall start it. We are now going on to, we just did magnetic field, and next is current carrying conductor in a magnetic field. Yusuf?
When would the object be shot outside of the current carrying coil if we place it inside? Because I've seen so many videos of they get the magnet and then they put the, unless it's another magnet.
We'll look at that. Yes. We'll look at that when we look. Well, it's not that difficult. You want to fire something?
Yeah.
What do you want to fire?
A ball, sphere.
Okay. It's helpful if the sphere has a charge, you see.
Yeah, that's why you know
yeah.
what side to put it in.
And what for these electric field guns, you have something. It doesn't have to be great. Like even something with a little bit of a spring that
Yeah.
fires it through a little hole through the electric field, and if it has a charge.
No. You make the coil, and that coil is
Oh.
and then
I'll have to look into that. I only know how to make a gun using electric field with parallel plates, not a coil.
Okay.
Okay, not of course, but